we're going to be talking about 3.5 equations of lines today. This is the moment that you've been waiting for when we start talking about slope-intercept form. So, as you recall, slope-intercept form, we mentioned this the other section, is y equals mx plus b, where m is the slope and b is the y-intercept. So, we use the y-intercept first when we go to graph, okay? And I want you to get in the habit of labeling both the slope and the y-intercept before you start the problem. And what you're going to do when you put down the y-intercept, you're going to use the directions of the slope to plot your next point. So 2/3. Rise, we go up, and run, we go right when they're both positive. So from this point, I go up 2 and then right 3. It's not from the origin from that point. Up 2 and right 3. Now, as you can see, this is a great way to get multiple points on the graph pretty quickly. What I want you to do, though, as well, is to think about how else this can be written. This can be written as -2 over -3. It's the same thing as 2/3. So I go down 2 and left 3, so completely the opposite, and that allows me to get points on the other side of the graph. And then we use a straight edge to connect them. If we look at number 2, we can see that this is in standard form. So what we're going to do is we're going to rearrange this so that we can get the y by itself. So when we get this, we notice that our slope is -3 and our y-intercept is -2. So when we put down the -2, I'm going to go back and make the slope a fraction. Anytime it's an integer, it's over 1. So the -3 means go down 3, but this is a positive 1, so it means go right. So when we go to plot this, and we go down 3, 1, 2, 3, and right 1. Down 3, and right 1. And again, the opposite of this would be +3, -1. So now up and left. So I go back to that 0, -2, I go up 3, left 1. Up 3, left 1. And then again, use that straight edge to connect. And again, we talked about this before. If we look at this first graph, it starts low and goes high, left to right. That's a positive slope. Whereas number 2, it starts high and goes down. That's a negative slope. The third form of a linear line that we're going to talk about is called point slope form. And this is an important one, especially when we go to write an equation for a line. In point slope form, looks like y minus y1 equals m times the quantity x minus x1. You'll notice with this form that there's only subscript here and here. So you are only plugging in one point, hence the form point slope, or the name point slope. You have the point and you have the slope. So that's what you're going to plug in. The regular x and the regular y stay the same, okay? So now we have 3 forms. We have standard, slope-intercept, and point slope. So in this section, it's asking us to write an equation of a line, first in slope-intercept and then in standard form. So you really have to think about what you were given. In number 3, it gives us the y-intercept and the slope. So this would be a perfect example of using slope-intercept form. We're going to plug in the slope here. We're going to plug in the y-intercept here. So when we go to do that, we're going to get y equals 5x minus 1/2. So there's our slope-intercept, okay? That checks the box for this first to do. The second thing that we're going to do is we want it in standard form. Now remember, standard form is ax plus by equals c with all integers. So what we're going to do is we're going to subtract 5x from both sides, and we get this. Now, the other thing is that I don't want any fractions and I want the leading coefficient to be positive. So what we're going to do is we're going to go back and I'm going to multiply by -2 to the whole equation, every single term. That will get rid of the denominators and this will make the leading coefficient positive. So what you're going to get is 10x minus 2y, and that equals a positive 1. And that's going to be our standard form. For number 4, you'll notice we have 3, 0 and -2, 4. -3, 0 is not a y-intercept. It is an x-intercept. So I cannot use slope-intercept form. This is where we're going to use point-slope form. But notice we have a point, but we need the slope. So now we go back to the idea of the slope formula, where we have to calculate the slope with y2 minus y1 over x2 minus x1. So it's going to be 4 minus 0 over -2 minus 3. So that gives us 4 over -5. So there's our slope. And we can pick any point we want, just need one. So I'm going to pick 3, 0. And now what I'm going to do is I'm going to use that point slope form. And I'm going to plug in where the slope is and also where that point is. So we're going to get y minus 0 equals -4/5 x minus 3. Okay, and then I'm going to distribute. Y equals -4/5 x plus 12/5. And so this is slope-intercept form. Now we're taxed with trying to make it into standard form. So I'm going to bring the x over the other side. So it's positive 4/5 x plus y equals 12/5. The last thing to do is get rid of any fractions or decimals. So we multiply by 5. And we're going to get 4x plus 5y equals 12. And then this will give us standard form. With number 5, we want to write an equation of the line, but we're not really given any information besides the visualization. So what we do is we look and we pick 2 points from the graph that go right through the lines. I can't use the y-intercept because it goes right between, so that's kind of hard to make sure that that's accurate. So we're going to use -3, 2, and we're going to use 3, -1. Now, I can either count to see what the slope is, so that's an option, which would be -3 and then 6 over. So our slope is -3 over 6 or -1/2. And again, I'm going to use point slope form. Y minus y1 equals m times the quantity x minus x1. And I'm going to plug in. Y minus, I'll use this point, 2 equals -1/2 times the quantity x minus a negative. So careful with those negatives, it's going to be a positive. So we're going to get y minus 2 equals -1/2 x minus 3/2. Again, because this one changed to a positive. Okay, and then we finish it up by doing y equals -1/2 x, and then if I add 2, it's going to be +1/2. So this technically is slope-intercept. And you can do a quick check. Does that look like it's hitting around half? And is it a negative slope? Sure. So it looks like we're on the right track. So we're going to add the x over to the other side. And then I'm going to multiply by 2, to get rid of the fraction. Then we have our standard form. All right, that's it for this lesson. We'll finish up the last couple examples tomorrow.